Hello and welcome to TN Academy. Today we are doing question 7, where we have a biologist that suggests some rate of change for a population of fruit flies after some time t equals 0, and the systems are given by the following equations. The rate of changes where x is the population of male fruit flies and y is the population of female fruit flies. Now the first thing we're asked is to find the eigenvalues to the corresponding matrix. Now to find the eigenvalues, we have to use the characteristic equation. We have to evaluate the characteristic equation where we say a minus less lambda I, it's the absolute value, is equal to 0. So to do so, we get our matrix, and we write it out, and we subtract the corresponding matrix. And with this, we can evaluate for the absolute value of our new matrix. And upon doing so, we should get the following equation. And then after expanding and simplifying, you should find the eigenvalues come out to be lambda is the eigenvalues are -10 and 5. Now, for our next question, we continue rather to evaluate the values for these given eigenvalues. First off, evaluating lambda is equal to -10, and we of course multiply for our x and y to solve for our system of equations and equate to our lambda value. And for lambda is equal to -10, our first potential values are -1 and 1. And then evaluating for lambda is equal to 5, we do the same process and evaluate for our system of equations. And we'll find that the eigenvalues should be 2 and 3. Now, for our second question, we're asked to rewrite our eigenvalues in the following format. Okay, where a, b, lambda 1 and 2 are scalar constants, and p1 and p2 are vector constants. Okay, and so we do so by restating our values with respect to lambda in the desired form. And we do not know the values of a and b, of course. And in question C, we are asked to determine their values such that x is equal to 500 and y is equal to 125. So we can substitute these values into our equation and then evaluate for a and b. And so we do that here, where we solve for a and b, where t is equal to 0, and x is equal to 500, and y is equal to 125. And we can solve for the two equations, or the two variables, simultaneously by first saying that x is equal to -a plus 2b, and y is equal to a plus 3b. And with this, we can substitute our values into the equation. Okay. Now, for question D, we're asked to state the long-term ratio of male fruit flies to female fruit flies. And that is simply 2 to 3. Okay? And then for our final two questions, we're asked to first find the value for the rate of change at t is equal to 0. And then for the next question, we're asked to sketch the trajectory of this on a phase portrait for the population of growth of fruit flies. Okay, so here we are. We'll try to find the rate of change at t is equal to 0, dy dx at t equals 0. And we first eliminate t by substituting for our conditions at t is equal to 0. Okay? And when we substitute our x and y respectively, we can evaluate for our equation dy and dx respectively. And then when we evaluate this, it should come out to be, after calculating, negative 3.5. And now, for question F, the final question, we are asked to sketch the trajectory. Okay? So to do so, we'll first start off by sketching out our grid. Where we have our 2 points of, this will be our y-axis and x-axis of 125 and 500. Okay. Then we can plot our point here, and we know from question E, given the gradient, that, make it a bit larger, the direction, the path of our sketch should be consistent with the gradient given by our evaluating dy dx in part E. Furthermore, we know that the diagram should contain at least one of their eigenvectors, such as equal to 1.5x, points 2, 3, of course not negative 1 and 1, and so forth. Okay? And the trajectory that passes through the point 125, 500 tends toward an oblique asymptote that corresponds to their eigenvectors, and the direction is indicated by at least one arrow along this trajectory. Okay? And that's all for question F. And yeah, that's all for this question today.